So in this video we are going to learn about left hand limit, which is called as LHL, and right hand limit, which is called as RHL. Right, so in the previous function, which was f of x, which was equals to x cube minus 8 upon x minus 2. So in this we got the when limit was x tending to 2, we got equals to 12 by an algebraic method. I'll show you here how, which was x minus 2 and x square plus 2x plus 4 upon x minus 2, and now it would be limit x tends to 2 and x square plus 2x plus 4. Now basically you substitute 2 into here, so you'll get 12. So this value is the 12 value. It does not show from which side, when we substitute x equals to 2, from which side on the number line the limit approaches 12. So let us say there's a number line and here's a x equals to 2. So from which side, from this side it approaches 12, or from this side it approaches 12? Or if those two limits, those two, when we say LHL is not equals to RHL, when the left hand limit it does not approach to 2, and the right hand limit, which was over here, which right hand limit and left hand limit, if does not equals to 2, then the limit does not exist, right? If and only if so we write his LHL here is limit x tends to 2 minus of a function here is x cubed minus 8 upon x minus 2, and we write RHL as limit x to 2 plus of a function. So these two limits can be different and can be equal. So we don't know the 12 which we got was the left hand limit or the right hand limit. So when we solve numerically, so when I'll write a function here so that you can see. So when we solve numerically, that here is f of x, and so if this is 2, the function at 2 does not exist, right? Because if you directly substitute 2 in here, it would not exist. So what we do is we take approaching value to 2. Let's take 1.9 and 1.99. Let's take here 2.001 and 2.01. Okay, so if you substitute x equals to 1.9 in a function, right, it would be 0.41, it would be 11.91. You can do it by calculator, and in here it would be 4.33 something and 4.3301, right? So when you round off these values go from 4 and these values come from 12. So what we can say that is when limit x from the negative side, so the limit is 12, alright, and x from the positive side, the limit is 4. So therefore, after calculating these two limits, I'll show you a generalized statement of limit existing. Okay, so if for example, let's take limit x tends to a, and we have to find this limit, alright. So f of x can be any of the thing, and a is here anything here, like constant or infinity or 0. So what we do in this case is we find the limit of x tends to a minus of f of x, and we find the limit of x tends to a plus of f of x. So for in this case these two limits were not equal, right? So x tends to a minus of f of x is not equal to limit x tends to a plus f of x. So in this condition, limit, I'll write it here, if condition, then limit x tends to a, f of x doesn't exist. If limit x tends to a minus f of x, if it is equal to, if both are equal, then limit x tends to a, f of x exists, which is in the above case it was 12, right? If no, it wasn't 12, it was 12 and 4. If both were equals to, for, like, say for example p, if both were equals to p, then this limit exists, and which is also equals to p, right? So this is the generalized statement. So this was left hand limit and right hand limit. If you have any questions, comment down below, and please subscribe to my channel for more videos. Thank you guys for watching.